one thing that I think I've seen very helpful in our work and with how our clients are using our platform is the fact that any problem, any data set from one to the other be very different in nature. Even a very similar problem, you kind of look at it again or maybe twist it a little bit and look to predict something slightly different, a little bit of a different behavior, like a response instead of a value, kind of a metric. You really can't know ahead of time what the right combination of predictors and what the interactions between things are going to be, and whether it's going to be linear or non-linear and how complex that might look. And so to me, a real benefit on the algorithm side of the AutoML platforms is their ability to pretty quickly sort through all those possibilities, right? So in the old days, thinking back a number of years, right, linear regression was sort of the way to go. And there's some nonlinear aspect, but it really required a lot of thought and, worrying about, whether the models that you're setting up, make sense at all, whether they handle all the complexities of the data, the interactions between the various predictors in the model. And sometimes they did and sometimes they didn't. But now we're really able to pretty easily throw a wide variety of algorithms that have different assumptions or maybe don't have assumptions and different levels of nonlinearity and complexity and interaction, and let the algorithms sort of go at it themselves and kind of compete against each other. So kind of just opens up, I think, a lot more to much more easily and at scale make better predictions.
Yeah, I think that's a really interesting change. And what I find, and even 25 years ago, when SaaS was getting bigger and starting to build some platform capability, and there was this talk of this automation would eliminate the need for the statistician, and today, we talk about the data scientist being that human involved, and maybe the ability to look at 5 or 6 different types of algorithms in a situation where some don't have assumption requirements and some do, and just let them perform against each other and do that in an automated fashion. Do we really need the data scientists to kind of guide that? And, I have found that amusing throughout my career, because there have been like more statisticians employed and more data scientists employed all along the way as we've gotten really, exponentially increasing levels of automation, right? So all of that software, the automation, the ability to do all that. So what is it that is really happening that requires, some finesse and some human intervention? And sometimes it's as simple as, well, what is the target variable that you're going to choose? And can we automatically choose between several different target variables and come up with the right solution for the business problem? And I've just found that automating those aspects of it are very difficult. There are a lot of times is quite a bit of finesse in figuring out, well, what is the target variable consumer behavior that we're after, and how does that particular data get captured, and what is that, and where is that in this data set, or how do we create it? How do we create an opportunity that actually creates kind of an automatic generation of a target that's going to then end up allowing all this automation to happen?